Welcome everyone. Today we are going to talk about function called stack. If a student asks me that what is the most important topic in programming or in understanding programming, I would simply say function called stack. Because in C++ in particular, you cannot understand the concept of dynamic array or static array or dynamic memory allocation and static memory allocation if you do not understand this particular concept. So let's dive into this concept and try to understand what it is. You have written a program in C++, you can see to the left of the screen. And when you execute this program, what happens? A memory block is allocated from RAM, which is random access memory. And this block is called the process address space. If we zoom in this process address space, only the space of the process which has been allocated to the program, then we can see there are different sections of this program. The source code will be allocated at the top of this particular address space. Then we have a special section where static and global variables are stored. And then we have heap and then stack. Now, if I declare a variable called x and its type is int, and I assign the value 23, what happens is that the main function is called, right? The program always begin execution from the main function, and all local variables declared within the main function will also be allocated on this stack frame. When the main function returns, when this return zero statements is executed, what happens is that all this memory will be destroyed, or in other case will be deallocated, right? Now let's take another example in which we have a main function, and the main function internally call another function called foo. If you look at the foo function, what it does is that it simply calls another function called bar. So when foo is called from main, first main will be allocated memory from the stack. Remember, from the stack, this is automatic allocation, because once the function returns, that memory will be deallocated automatically. So then foo is called, and then foo calls another function called bar. If you look at the bar, this is the bar function. What happens is that the bar then call base. This is another function. And base function does not call any other function, but it has some code that will be executed. Once the base function finishes execution, then the control will get back to bar function, and that stack which was allocated to the base will be automatically destroyed. Then again, when bar finishes execution, because there is nothing in the bar except that it called base, then that stack frame will also be deallocated, automatically destroyed. Simply, when foo finishes execution, the stack frame from the stack will be deallocated, and simply when the main function returns, stack will be empty. So this is called automatic memory allocation. That's why when you declare a variable inside a function that lives inside the function or that exists as long as the function is running, once the function finishes execution, that variable and everything is gone within the body of the function. So as you have observed that as we call more and more functions, the stack grows upward. And remember that the size of the heap and the size of the stack is determined by the operating system, and it's limited, it's not unlimited, because there are other programs running in your system and they also need space. So sometimes if you have infinite recursive call, if a function is calling itself again and again and again and it never ends, you will run out of space and you will get a segmentation fault. And similarly, if we have heap, which we have not discussed yet, we are going to discuss this topic next, then the heap grows downward. So sometimes they collide when there is no more space for the heap or there is no more space for the stack, then we get segmentation fault. Now, dynamic memory is allocated at runtime by the operating system based on request by the process. And the new keyword is used for this purpose in C++. So if you have seen the new keyword while declaring a variable or declaring an array or declaring an object or declaring a variable of structure, remember that the memory is allocated at runtime, and that memory will be allocated from this section which is called the heap. So heap is utilized for runtime memory allocation by the operating system. And once you get the memory out of the heap, you must release that memory yourself. And for that purpose, we use the delete keyword in C++. Delete does not mean that delete memory from the heap, but rather it is a signal to the operating system that you can reclaim this memory or release this memory because we no longer need it in our program. And why do we delete it? Because if you do not delete the memory and your program is running for a long time, you might be running out of space, and this is what we call memory leak. You have acquired memory from the heap, you are no longer using it, and now you have not told the operating system or given signal the operating system that reclaim it. So that memory will still be reserved as if it is being used by your program as long as the program is running. So it is always a good practice that once you acquire the memory from the heap using the new keyword, you should always use delete once you do not need it. And we will see that practically in the next video. So for example, if you declare an integer variable and you want to declare that integer variable on the heap, you want the operating system to allocate memory from the heap, you use the new keyword in int, which is the data type, and the new keyword does two things. The first thing is that it requests the operating system to allocate memory from the heap, and the second, it returns the address of that allocated space for the integer. So we have reserved a memory block here using the new keyword, and then it returns the address of that memory to that particular pointer. There is a difference. New int means we are requesting the operating system to allocate integer on the heap, right here. But int star ptr is locally dictated within the main function, so it is on the stack, but it is holding the address of that particular memory block which was declared in the heap. So always remember that if you want to release this memory, you use the delete keyword. And now if you want to put something here, we use star ptr, which is dereferencing the pointer. In other words, it means go to the address to which the pointer is pointing and put the value 10.